7. Okay, so they're giving a formula for the tide and the height of the tide. And we have h of t is equal to 1.46 times the sine of pi over 6t. Was it plus or minus? Plus 1.56. Okay. Now, let's think of it as f of x is sine nx, or sine nx, okay? Or even a sine nx. What do we know about a function that looks like that? We know that the range of the function goes from minus a to plus a. We know that the period of the function is 2 pi over n, okay? So we have spoken about this in radians, okay? It's 2 pi or 360 over n in degrees. So what does that mean? That means this is a sine function, okay? Now, this isn't just an a times sine nx, it's a times sine nx plus 1.56. So it's a sine function that has a certain period and a certain amplitude, okay? That normally looks like that, but in this case, it's going to be shifted up, like f of x plus c, it's shifted up by 1.56. So instead of being centered around 0, this sine function is going to be centered around 1.56. So a rough sketch of this function would be something like, very rough sketch, if this is 1.5, 1.56, it's going to be a sine function that is centered around 1.56. Okay, now what about its amplitude? Well, its amplitude is 1.46. That means the amplitude, remember, of a sine wave, that's the a there and the a there. It's the height. So our sine wave is going to go between 1.56 plus 1.46, which is 3.02. Our sine wave is going to go between 3.02 and 1.56 take away 1.46 leaves you with that would be 0.1. Okay, so 1.56, the biggest it's going to go is 1.56 plus 1.46, the smallest will be 1.56 minus. That doesn't look very well centered. I might just put that a wee bit higher. So that looks a wee bit better. So that's 3.02. Okay, so we know it's a sine wave and it does this. Along the bottom, again, a sine nx. Our x is our t. That's our variable. So this is t. Okay, the period of a function is 2 pi over n. In this case, our n is pi over 6, sine nx. So 2 pi over 6 is 12. So the period of this function is 12, is the units in hours, I think. So 12 hours. So this function is going to repeat itself every 12 hours. All right, so if I was to do this, that means that this is 12 hours. And I think it says it starts at midnight. So let me just double check. Midnight, yeah. The mean sea level occurs at midnight. So the mean sea level occurs at midnight. Okay, so the questions. The depth, find the time at which the first high tide occurs. So the first high tide is going to occur here, okay? Our mean starts here, so our 0 point is kind of here. Well, if the period is 12 hours, which we've worked out from here, then halfway here is 6 hours, and this is halfway again, so this is at 3 hours. So at 3 o'clock in the morning will be when the high tide occurs. What is the depth of the water at that time? Oh, we can see just from looking, it's 3.02 because it's the center point, 1.56 plus 1.46. So it's 3.02 meters. The next bit, what's the period? Well, we've already found the period, so the period is 12 hours. Then they give you a load of x, y's, or at least they give you the t values, and you guys have to work out the h of t. So they're giving you time for 0, 3, 6, and they're getting you to plot the point. So that should be straightforward. Your graph should come out something like that. Sketch the graph. Okay, well, I've already sketched a graph, so that should be okay. Now, my graph is not accurate. A cruiser wishes to enter the marina to refuel. The boat requires a minimum water level of 1.35. When it's fully fueled, it requires at least 1.65. Use your graph to estimate the time interval for which it can enter the marina in order that it is not grounded if it's refueling. Okay, so it refuels, it takes 4.5 hours to refuel. So we need to find a point on the graph. Actually, let's just identify 1.65 roughly. My graph is not going to be accurate. Okay, so, gosh, very inaccurate. 1, 2, that's very inaccurate. 1.65, let me look and see what they have in the market scheme to get close to it. 1.5, 1.65. Okay, we'll say around here somewhere. So this is 1.56, remember. So this will be about 1.65. Very badly. Now I'm just literally guessing at it here. Okay? Not even drawing a straight line either. Okay. Right, so this, remember, keeps going. Okay. That's 12. That will be 15 hours. I may have needed to have gone further. So 17. 15, 16, 17, 18 hours. Anyway. Okay. So it takes 4.5 hours to refuel. That's the 1.65, and the other one was the 1.35. 1.35 is probably about here. Okay, just guessing on my graph. So that's 1.35, that's 1.65. And what we need is at least 4.5 hours from when it's 1.65, it can enter 4.5 hours earlier, as long as 4.5 hours, over that 4.5 hours, it never falls below 1.35. So in my opinion, and it's not in the marking scheme, there is nothing stopping it can leave here, okay, at this time here, because 4.5 hours earlier, it will definitely be above 1.35. So even if it enters at midnight, it's above 1.35, and 4.5 hours later, 4.5 hours is here, it's still well above 1.65. So it should have no problem entering at midnight and leaving at no stage. Oh, hold on. Yeah, no. At no stage does it drop below 1.35. Okay, unless I've read it wrong. Let me just read it again, but as far as I know, it says when it's fully fueled, it needs 1.65. Yeah, I don't see why it can't enter at midnight and leave 4.5 hours later, or even take any time from here and take 4.5 hours back. It can enter at any stage there, as long as the 4.5 hours, by the 4.5 hours, it's still at 1.65. Anyway, I think that what the marking scheme does is it does the same, except it does it over here. So basically, I think the marking scheme is saying, obviously at no stage here can the boat be doing anything, right? Because even if it gets above, let's see, if it gets above 1 point, it can enter at this point here, okay? It can enter at this place here. I don't know what time that is. You'd have to read that from your graph. I think that's the one that they say is 11.44. So they're saying this is 11.44. It can definitely enter from here on, and 4.5 hours, it's plenty, and really it can afford to leave as long as it's around here. So it will be leaving, it has to leave by 7, what is that according to their graph? 17.53. So they're saying that's 17.53 here. So really 17.53 would be when it would be leaving. 1753, although I don't see why it couldn't be leaving here as well in a similar way. And it could enter. So it would take 4.5 hours from 1753. So 4.5 hours from 1753 would give you 1323. So 1323. That's the latest that it could arrive and still be able to leave. Okay, so in terms of the answer to the question that they've given on the marking scheme, they have 1323 and 1144. So the question was the time interval for which it can enter the marina. So it can enter the marina here at 1144, and it can still enter all the way up as far as 1323, because it still has 4.5 hours to refuel and still be able to leave with the water at 1.65. I'll go into it in more detail if anybody wants me to. I personally think it can also enter at midnight. Nothing stopping it. It can also enter at midnight, and it looks to me that it is 1.65 somewhere here at 5 point something. So if you subtract 4.5 hours from 5 point something, it can also enter between midnight and that time as well. But that's not in the marking scheme. Okay, hope that makes sense. Sorry, it's all squashed into one corner. The next bit. The next bit is find the rate at which the depth of water in the marina is changing at 8 o'clock. Find the depth of water, the rate at which it is changing. The depth means the height, so dH by dt. Find dH by dt, and they said at 8 o'clock when t is 8. Okay, so h is equal to 1.46 times the sine of pi over 6t plus 1.56. So what's dH by dt? dH by dt is, again, that's like a sine bx plus c. So it's the 1.46 is just a constant. When you differentiate sine, you get cosine pi over 6t. But that's the sine of, it's the same as if you differentiate sine 6x, you will get cosine sine u. When you differentiate sine u, you get cosine u, but then you have to multiply by the u bit differentiated. So we're in here, when we differentiate sine pi over 6t, we get cosine pi over 6t times pi over 6. And then when you differentiate a constant, you get 0. So now what we need to do is, so it's 1.46 multiplied by pi over 6 multiplied by the cosine of pi over 6 times t. And t in this case, because they want us to do it when t is 8. And that works out, to save myself a lot of time, that works out as minus 3.8, not minus 0.38 meters per hour. And check that if you like. I don't think I've made a mistake, but where did the minus come from? The minus comes from, that turns out to be 4 pi over 3. So if you think about it, what's the cosine of 4 pi over 3? The cosine of 4 pi over 3, 4 pi over 3 is 180 plus 60, so it's 240 degrees. That's somewhere in here. And we know, all silly Tom cats, in here cosine is negative. Okay, so that'll be a negative answer. I think it's minus 0.5, but that is negative. What does that mean? That means that at 8 hours, which is somewhere around here if we look at it, somewhere here, the rate of change of our function or our height is decreasing over time as time increases. Okay? Right, the next bit. Hope that light isn't getting in the way of things. Part C. Hence find the other times at which the depth of the water is changing at the same rate. Okay, so we want to find the other times at which the depth of water is changing at the same rate. Okay, well let's put dH by dt when t was 8. We'll put it up here and its value up here, okay? So dH by dt was you had 1.46 okay, what was dH by dt again? It was 1.46 by pi over 6. Then we're going to have to multiply this out by cosine 4 pi over 3 when we put the 8 in. Okay, the cosine of 4 pi over 3 is minus the cosine of 60, I think we found. And the cosine of 60 is a half, so that's minus a half. Okay, so dH by dt was 1.46. Does 6 go into that? Not exactly. 1.46 pi over 6. So according to that, they've tidied that up to 73 pi. Oh yeah, okay, 73 pi over 300. Right, if you put that into the calculator, 73 pi over 300 times minus a half. Okay, and we want to know what are the other times at which the depth of the water is changing at the same rate. Okay, so the depth of the water is changing at the same rate at what other times? So you've got 1.46 pi over 6 times the cosine, and this originally was what was it? It was pi over 6t. That's dH by dt. Okay, and dH by dt when t is 8 is that, and they want to know what other times is dH by dt equal to 73 pi over 300 times minus a half. Okay, or 1.46 times pi over 6. Yeah, we could just leave that as 1.46 times pi over 6, and I can leave that actually as 1.46 times pi over 6, because now we can divide both sides by that. So what we're really saying is, when is cosine pi over 6t equal to a half, minus a half? So for what values of t is cosine of pi over 6t equal to a half? Okay, so cosine pi over 6t, sorry, that's not right, pi over 6t is equal to a half, minus a half. So let's just say cosine of A is equal to minus a half. What are the values of A for which cosine A is minus a half? Okay, well, we just agreed that the cosine of 60 is a half. It's plus a half because cosine is positive here, but cosine is negative here and here. So we know that for this angle here with the 60 here, this angle will also have a cosine of minus a half, as will the angle here. Okay, this is the one we've already spoken about. This is the 240 that corresponds to that angle when t is 8. But what about this one? So we know that the cosine of A is minus a half when A is equal to 180 minus 60, which is 120, 180 when A is equal to 180 plus 60, which is 240, and all of those numbers plus 360n. That's if we're in degrees, but if we're talking in radians, since we have pi's, we should stick with radians, plus 2 pi n, plus 2 pi n. So a, whenever a is 120 plus 2 pi n, for n going from 0, 1, 2, or 240 plus 2 pi n, then we know that the cosine of a is minus a half. This is our a. So what we're saying is when pi over 6t is equal to 120 plus 2n pi, or when pi over 6t is equal to 240 plus, oh, I'm saying, sorry, I should have put them into radians as well. So 120 is what? That is it's pi, take away pi over 3, so that's 2 pi over 3. And 240 is 4 pi over 3. So that should be 2 pi over 3 plus 2n pi, or pi t over 6 equals 4 pi over 3 plus 2n pi. Okay, now we can divide by pi. So t, and multiply across by 6, t is equal to 4 plus, multiply across by, plus 12n, or for n equal to 0, 1, 2, 3, 4, or t is equal to, multiply across by 6 and divide by pi, we get t is equal to 8 plus 12n. Again. So in other words, t can be 4 when n is 0. T can be 8 when n is 1. Sorry, 16 when n is 1. So 4 hours, 16 hours. When n is 2, that's 28 hours, and so on. Or t can be 8, which we already had. It can be 8 plus 12, which is 20 hours. It can be 24 plus 8, which is 32 hours, and so on. Okay? Hope that helps.